Now, topic is electronic balance. Now, electronic balance is used to measure mass, and it can measure mass in kilograms, grams, or milligrams. Depends on the sensitivity that you need or the range that you are measuring. You can set different ranges in different electronic balances. Now, all we have to do in case of a solid, it is very easy. Just the put the solid on the top of the electronic balance, and your screen will give you the reading. Okay, this is all you have to do. In case of a solid piece of metal or piece of wood or plastic, it is very easy to just put it on the electronic balance and record the reading. Okay, but in order to do that, you have to check for the zero error. First, your electronic balance should be completely empty. It should have nothing, and there should be zero on the electronic balance. And then you put that object on the top and you record the final reading. For example, this person has put 50 pennies and he is seeing 125.30 grams. So it means 50 pennies weigh about 125.30 gram. So each penny will be 125.3 divided by 50, which will be 2.506, I think. Okay, so you can use a calculator to find out. Uh, Averagely, each penny will have a mass around 2.506 grams. So this is how we can measure using electronic balance. But in case of measuring mass of some liquid, it is important. Like we cannot put liquid on the electronic balance just like that. We have to put liquid into a container. But the problem is then in containers, mass will contaminate the reading. What to do? For that, some new uh, electronic balances, they are provided with this zero button, or in some electronic balances it is labeled as tear button. Okay, so this one reads zero. So what happens is you put the container on the top, the empty container on the top, and then you just press this button. The time you press the button, whatever is on the electronic balance, the reading over here becomes zero. Now, if you add something to the container, its mass will be shown on the electronic balance. So it will only be showing the mass of the thing that you are adding to the container. So electronic balance, to measure mass, just put it on the electronic balance and record the reading on display. If the object is a solid. But if it is not, but if it is liquid, if object is a liquid, first put an empty container and record its mass. So this is the mass that you need to minus from the final reading, but this is only the case if your electronic balance is not provided with this zero button. Mhm. Or
Okay, sir.
press zero to make reading zero. Now add liquid to container and measure mass again. Make suitable adjustments if needed. So this is how we can measure mass using electronic balance. Now, the next measuring device is measuring cylinder. This is measuring cylinder. Now, in order to use a measuring cylinder, we have to, number one, use a suitable measuring cylinder with appropriate height and diameter. The one with thin diameter, one with thin diameter are more sensitive. The one with more length or height are or have more range. So if you have a lot of liquid to measure the volume of, you need a taller and wider measuring cylinder. Now, things you should be careful with. Number one, measuring cylinder must be vertical while you take reading. Number two, Liquid surface should be stable. 3. Line of sight should be perpendicular to scale to avoid parallax error. Let me push this picture down. Now, when we look at the measuring cylinder and we are taking reading, we do not see one surface. Look, this is an actual picture of a measuring cylinder using measuring water. And you can see that we are not looking at two readings. If you focus, you will find that you can either record this reading, you can either record this reading, or you can either record this reading. So there are two readings. Which one will be the correct one in this case? One or two? Which one will be the reading, or which one will be the volume of liquid right now? Like, for example, this is 20, so this will be 21.5, 21.6, 21.7, 21.8, and 21.9. So we are having 21.8, 21.7, and 21.9. What reading you should present as the reading for the volume of liquid in the container? Okay. Sometime, and this double surface, this is because of the cohesive and adhesive forces between the molecules, and they cause this. And we don't need to know the arrangement. Like in this case, the cohesive are stronger than adhesive, and in this one, adhesive are stronger than cohesive. So the arrangement of this thing, which is known as meniscus, becomes like this or like this. So when it is like this, we take the bottom reading, and when it is like this, we take the top reading. Why? Because in case it is like this, most of the liquid level is here. So that's why we consider this one as the volume, then this one. So
Okay, sir.
volume of liquid is taken from the mid side. Like if you forget, you have to look at the mid of the meniscus. If the mid of the meniscus is at the top, that will be your reading. And if the mid is at the bottom, you will take bottom as the reading. So fourth point is mind meniscus for convex meniscus. Take the top reading. For convex meniscus, take the bottom reading. So this is how we have to be careful about the meniscus. Now, the fifth point is tap the measuring cylinder gently before taking reading. This will remove air bubbles, air bubbles in the liquid, if any. Sometimes when we put some liquid in the measuring cylinder, there are some um, very small air bubbles formed. And when we tap measuring cylinder gently, it will remove any air bubbles and you'll be able to measure the actual volume of the liquid. So it will remove the air bubbles from the liquid. And there are always some air bubbles. In some cases, there are more air bubbles. For example, if you have ever put a soda in a glass or 7-Up or Sprite, that like transparent carbonated drink into a glass, you might have noticed air bubbles. Okay, and that
Yes.
is the case. That is the case. We have noticed too many air bubbles. Uh, uh, just a minute. This is the one. So if we are able to see this one, you will find that when we put a soda in a glass, there are some air bubbles formed. I hope you can see this one.
Yes, sir, I
So,
can.
so these are the air bubbles formed, and obviously, if they are occupying some space over there, this level of liquid is not the actual level of liquid. This is the level of liquid, and this all air that all these bubbles are having. So if we like these are the air bubbles that you can see. If there is an air bubble, there is a air bubble in the middle of the liquid that you cannot see, then you would never know. But tapping the liquid is helpful if there are smaller amounts of air bubbles. You cannot remove these many air bubbles by tapping. Okay. But if there is a two or three bubble that we can or cannot see, and you tap gently the liquid, top of the liquid, some people stir the uh, measuring cylinder a little bit. They turn it left to right. So they're trying to remove any air bubble in between, and then they can actually find the true volume of the liquid inside. So this is already discussed that when we are taking reading, the line of sight must be perpendicular. If your line is like this or like this, you are making parallax error. This is what we call parallax error for measuring cylinder. This is parallax error. And parallax error is caused by improper position of eye. This is wrong, wrong, and this is correct position. So if you use the correct position, in that case, you will have uh, the exact reading, and the correct position means the perpendicular to the scale. The line of sight must be perpendicular to the scale. Uh, Correct as line of sight is perpendicular to scale. So now these are the things that we need to be careful about. In the next lesson, we'll be solving some past paper questions regarding all this. Thank you very much.
Okay, sir.
Okay, take care. Allah Hafiz.